Hello, welcome back to Digital Urim. In the previous part, we explored the foundations of logs and events. We learned that logs are not just technical records, they are digital evidence. We also saw how login activity can reveal suspicious behavior, like the example of impossible travel, where a user appeared to log in from two different countries within hours. Now, in this second part, we are going deeper, because understanding logs conceptually is important. But reading real logs is what turns knowledge into skill. Today, you will see how real logs look in Windows systems, how failed login attempts appear, how privilege escalation is recorded, and how Linux systems generate their own critical logs. This is where analysis begins to feel real. Until now, we worked with simplified logs, but in real organizations, logs are far more detailed. One of the most common systems used in enterprise environments is Microsoft Windows, and one of the most important places where activity is recorded is called Windows Event Viewer. Inside this tool, every important system activity is recorded as an event. Each event has something called an event ID. An event ID is a numeric code that identifies a specific type of activity. For example, a successful login has one event ID, a failed login has another, administrative privileges have yet another. Let's look at a simplified real-world example. Event ID, 4624 event type, successful logon user, JSmith logon, type, 3 source IP, 192.168.150, time, 08.15. This event tells us a user named JSmith successfully logged into the system from a specific IP address at a specific time. The number 4624 is extremely important because it represents a successful login, and successful logins are not always safe. Sometimes they are the beginning of an attack. Now let's look at another extremely important event: failed login attempts. These are recorded using event ID 4625. Here is an example. Event ID 4625 event. Type, failed logon user, JSmith source, IP 203.0.1345. Failure reason, bad password time, 08.17. This means someone attempted to log in, but failed. A single failed login is not always suspicious. People forget passwords. That happens. But multiple failed logins in a short time can indicate something very different. For example, password guessing, brute force attacks, credential stuffing. If you see 10 failed logins in seconds, that is not normal behavior. That is a signal. And signals are what analysts investigate. Now we move into one of the most critical phases of many attacks: privilege escalation. After gaining access, attackers often attempt to increase their permissions. Why? Because administrative privileges provide control, and control leads to impact. Here is an example event. Event ID 4672. Event. Type, special privileges assigned. User, JSmith privileges, administrator. Time, 0819. This event indicates a user received special administrative privileges. Sometimes this is normal. For example, a system administrator logging in, but sometimes this is the moment an attacker gains control. This is why privilege-related logs are among the most sensitive events in cybersecurity. Now let's move into another world: Linux systems. Linux is widely used in servers, security tools, and enterprise infrastructure, and Linux generates logs in a different format than Windows. Here is a simple example. Failed password for root from 192.168.1 bounds 100, port 22 SSH2. This message tells us someone attempted to log in as the root user from a specific IP address using SSH, and the login failed. This is extremely important, because repeated failed attempts against root accounts can indicate brute force attacks. Later in this course, you will learn how to analyze Linux logs in depth. For now, this is your first exposure, and it matters, because Linux will become a central tool in your cybersecurity journey. Now let's talk about real mistakes that happen inside companies. Mistakes that turn small incidents into major disasters. First mistake: not storing logs long enough. Some organizations store logs for only a few days, but many attacks are discovered weeks later. If the logs are gone, So is the evidence. Second mistake, not centralizing logs. If every system stores logs separately, patterns become difficult to detect. Third mistake, not reviewing logs. Logs exist, but no one analyzes them. That is like installing cameras and never watching the recordings. These mistakes are not technical. They are operational, and they are dangerous. This is where professional thinking begins. A real analyst does not see logs as text. They see behavior. They see patterns. They see anomalies. Here are the types of questions a real analyst asks. Is this login normal? Is this location expected? Is this time typical? Should this user have this level of access? A regular user sees information. An analyst sees meaning. And that difference defines professional capability. Today, you learned something critical. Logs are not just technical records. They are digital evidence. You learned how events represent actions, how logs record those actions, and how alerts highlight potential threats. You also explored Windows login events, failed login patterns, privilege escalation indicators, and your first exposure to Linux logs. But now we move forward, because logs show what happens, but networks show how activity moves. In the next video, you will learn how data travels, how systems communicate, and why understanding networks is essential for interpreting logs correctly. Because without understanding networks, logs are just text. But with network knowledge, logs become live evidence. Understand, defend, grow.